All right, now that we've implemented sync and swim, we have a good shot at implementing the priority queue operations. So let's take a look here. I actually already have the code on the slide. It's really simple. So let's look at first the idea of implementing insert. Insert for priority queue means I just want to throw something in there. Well, hey, insert basically just corresponds to looking inside the PQ, going to that array, very last slot, throwing an element in, and then doing a swim operation, right? So we can imagine we have here, right, our array over here, right? We have a new element, add it in over here, say it's a number 5, right? That's the equivalent of v equal 5 over here, right? So we're going to add it at the very end, right? You don't want to mess with the contents of it, right? We want to add at the very end. It's at the very end. Do a swim on it, right? And so wherever it's at, right, it'll basically be pushed all the way up. Note that adding it over here, that's basically the equivalent of adding it in like the complete tree ordering, right? So we're going to add it, when we add it to the very right-hand side of that array, that's the equivalent to adding it to the lowest level and then like the rightmost free space. So basically it's going to always keep our tree complete. So it'll be complete, right? And we know that tree is complete, but it's maybe not a heap because it could be out of order. So we do that swim operation, brings it up into the right position. So yeah, that's what we're doing there. And you can see it's kind of diagrammed over here on the middle over here, right? So it's like, well, I have a tree, add a node, add it to the complete position, right? This is where it would be, right, if we weren't trying to keep it complete. And after it's added there, just do that swim, move it back up to where it belongs. So yeah, insert, pretty straightforward. Second thing here, right, is delmax. Delmax is a little bit more work, but not bad. So first thing is, right, we got to pull out something, right? So we want to pull out the max node. So that'll end up being stored over here as our max variable. So that's pretty good. And then what we're going to actually do, and maybe the picture shows it a little better, is we're going to reach into that heap and grab the very last element and put it at the max position. So notice over here in this original tree over here, right, which you can look at for a second, T was the max. A bunch of other stuff, it's all ordered, it's all good. Then H kind of is the very, very last node in there, right, in terms of like the complete ordering. That gets moved up, right? So T gets knocked out. Instead, we get H there in its place. Okay, that's actually this code over here, right? So it's CS exchange. We're going to the very end, pulling it back up, right? So n minus minus is basically that last position. 1 obviously, right, is our very first node in there, right? So we're taking that last node, pulling it all the way back up. All right, so we have it there at the very beginning. Now, right, maybe it's out of order. So in that case, right, we do our sync. So the sync, right, is basically going to look at that one node, right, and push it down to where it belongs, right? So over here in our example, it's like we start here, we went down, replace P. So we have our sync over there. That line that I kind of skipped over there, PQ of n plus 1 equal null, what that's doing is basically deleting the old element, right? Because we don't want to have too many things in there, right? We don't want to have an extra element. Strictly speaking, we don't really need that step. But it's kind of good to clean up after ourselves, right? We don't want to have multiple references to something if we only want to have one reference to it, right? So we'll kind of null out that kind of extra one that's created. So yeah, our topmost element is stored in the max variable. We moved up the one that was at the very final position, put it up top, then sunk it down to be at the proper position, and then we can return our max, right? And that'll be the maximum, right? It's been removed, we're good to go. So there you have it, our implementation of insert and delmax. Both are very straightforward, given that we have sync and swim available to us.